The question, why are we all here, used to be the purview of religion. The Bible claims that God created the universe and human beings by His word. The universe was literally spoken into existence. Many creation stories, such as the one in the book of Genesis, propose the universe was created ex nihilo, or out of nothing. Others propose a primordial chaos that was shaped by a creator being or some diver creature, building the lands out of primordial waters. In the 20th century, physicists have taken over the role of high priests of creation. They now control the story of how the universe came into being. At first, they believed the universe was static and eternal. Then Einstein's theory showed that it must not be static but growing, implying it had a hot, dense beginning. We infer this is true from numerous observations. What we don't know is how the universe got to be the way it is. This is called fine-tuning. Fine-tuning is the idea that the physical constants of the universe appear to be finely tuned for the appearance of matter, and therefore life. A common objection to fine-tuning is that, well, no, life adapted to whatever was here. Life is finely tuned to the universe, not the other way around. That is an ignorant statement at best. If there is no matter, then how can there be life? If, for example, the balance of mass and energy in the universe were not precise, the universe would simply have collapsed back in on itself. If other features like proton masses were different, we wouldn't have elements. There would be no building blocks. It is as if we came upon a world made of beings made of Lego. We inferred that world must be finely tuned for Lego life, and someone objected, saying no, life simply adapted to the existence of Lego. The issue isn't that the building blocks are Lego. The issue is that there are building blocks at all. As King Lear said, nothing will come of nothing. The universe is finely tuned to have elements that assemble into larger, more complex objects. That is required for life to exist. There are far more universes we can conceive of, using the constants of nature we know of, that contain literally nothing at all or nothing that can build on itself. Even the chance of stars existing is considered to be astronomically improbable. Life requires complexity. It cannot exist within either a chaotic universe, where everything is moving too quickly and changing too fast for organization to build, nor can it exist within an overly orderly universe, where everything moves in smooth, periodic orbits, and nothing unexpected ever happens. Fine-tuning is a real problem. One potential solution to fine-tuning is the Anthropic principle. This principle states that the universe is finely tuned because we are here to observe it. If it weren't so, then we wouldn't be here, and nobody could ask the question. This is a neat but unsatisfying philosophical answer because it assumes the universe just appeared randomly with no explanation. There are, in fact, a large number of possible universes in which human life could exist if produced randomly. The simplest of these is a Boltzmann brane universe, attributed to Ludwig von Boltzmann, one of the fathers of statistical mechanics. In this universe, we are simply brains containing fake knowledge about the universe. We think we are here in some corporeal form for some duration of time when, in fact, we just got here, we are leaving in the wink of an eye, and all this is an illusion. We can't disprove that we are in a Boltzmann brane universe because our knowledge is fake. We have no information to go on. A similar, more modern version of this argument is the simulation universe. In this case, as philosopher Nick Bostrom has argued, we are living in a simulation created by our descendants, or maybe some other alien species living in another universe, perhaps the real one or maybe another simulation. Bostrom has used Bayesian reasoning, meaning probability based on beliefs rather than measurements, to argue that we are more likely to be living in a simulation than a real universe. He reasons that it is far easier to simulate a universe than to make a real universe. Therefore, there must be more simulations than real ones. Ergo, we are in one. This is a nice bit of reasoning, but based on a string of unsupportable and hardly self-evident premises. Unlike the Boltzmann universe, we would be living in this matrix and so have knowledge about the simulation. But like the Boltzmann universe, our knowledge is fake as it pertains to the real universe. The simulation hypothesis does not directly solve the fine-tuning problem because it presumes there must be a real universe somewhere. That universe must be finely tuned for all these simulations to exist, unless the universe simulation is itself a collective Boltzmann brane. If the simulation is perfect, in that we cannot tell that we are in a simulation in any way, then we reach a dead end in our questioning of reality. We have no access to it. If the simulation is imperfect, then there is hope we can determine that we are indeed in one. Are there glitches in the matrix? Perhaps, but we haven't detected any that cannot be explained as natural occurrences. Philosophically, we can dismiss these two ideas, Boltzmann brains and perfect simulation hypothesis, on the basis that they call into question all the knowledge we have about reality. Thus, we can go no further with them as basis for understanding the world. We have to believe that we have at least some access to reality in order to make progress. It is therefore a practical requirement that we be living in a real universe or have access to it. A viable and popular explanation of fine-tuning is the eternal inflation multiverse theory. In this theory, our universe is one of many, many bubbles within a vast multiverse. Each universe appears within the multiverse as a false vacuum. A false vacuum is what allows matter and energy to exist. In a true vacuum, nothing can exist. Therefore, false vacuum is genuine creation ex nihilo. Each universe in the multiverse starts with a different set of constants. Therefore, each bubble is like a little planet. The analogy is a powerful one. Most planets in the universe are lifeless because they do not have the correct conditions for life. Because there are so many planets in the universe, however, there must be a certain percentage that do have those conditions by pure probability. Universes work the same way. There are a vast number of them within the multiverse, and most of them are lifeless. In fact, the vast majority of them do not even get started. In the same way that the universe is full of a lot of dust and clumps of matter that is not part of a planet or a star, the multiverse is full of a lot of failed false vacuum bubbles that collapse in on themselves or tear themselves to pieces. Only a few of the universes that start continue to grow and become full-fledged universes. Of those universes, only a few have the right conditions for matter to exist. And of those universes, only a few can produce matter of sufficient complexity that it can build by the process of evolution into life forms. Thus, as the Earth is a rarity within the universe, so the universe is a rarity within a greater multiverse. This is a neat idea, but it suffers from a number of problems. Some have to do with the details of the theory, others are philosophical objections. One issue with the theory is that it depends on the multiverse sharing time across universes. Things are happening across the multiverse at the same time. How you measure time determines how universes appear and how likely they are. As we delve deeper into the mysteries of our universe, we stumble upon an intriguing hypothesis, the idea that the universe itself might be a living entity. This concept, known as the living universe hypothesis, suggests that the universe is not just a static collection of matter and energy, but a dynamic, evolving organism. Imagine for a moment that the universe is akin to a giant living cell. The galaxies, stars, and planets are its organelles, each playing a crucial role in the overall functioning of the cosmic organism. Just as cells in our bodies undergo processes to sustain life, the universe might be undergoing processes to sustain its own existence. This hypothesis raises profound questions. Could the universe possess a form of consciousness? Could it be self-aware, capable of growth, adaptation, and perhaps even reproduction? These ideas might sound far-fetched, but they are rooted in the same spirit of inquiry that has driven humanity to explore the cosmos. The living universe hypothesis also brings a fresh perspective to the fine-tuning problem. If the universe is a living entity, then its fine-tuning might not be an accident, but a result of its own internal processes. Just as life on Earth has evolved to adapt to its environment, the universe might have evolved to create conditions favorable for its own existence. This idea finds some support in the field of cosmological natural selection, which posits that universes might reproduce through black holes, with each new universe inheriting the physical constants of its parent. Over countless generations, universes with favorable conditions for stability and complexity would be more likely to survive and continue the cycle. Of course, this is still speculative and far from being a proven theory. Yet, it opens up new avenues of thought and invites us to consider the universe in a more holistic and interconnected way.